y equals 4 minus 2 sine, and if you factor it out a 3, class, what are you left with?
X minus pi over 3.
Raise your hand if you got that. Okay, now we can write the letters below it or above it, d plus a sine b parentheses x minus c. Now I'll answer the question why I wrote d later on the left side, why I'm putting d over here. So my a value is a -2. Therefore, my amplitude is a your b value is what? Raise your hand if you got the period to be 2 pi over 3. C value is pi over 3. That means our phase shift is which direction? To the right, pi over 3. Remember, add to x, go west or left. Class, what's our d value? So it means we have a vertical shift where? Alright, in this problem, I know the length of the period of the graph where it starts and it ends will be 2 pi over 3, but I want to know specifically where it starts and where it ends. So I'm going to put all of that between 0 and 2 pi. Now, I'm going to put in the factored one. Class, what am I putting here? You could put 3x minus pi and get the same answer. You'll have to add pi and then divide by 3 is fine. So here I'm going to divide by 3. I get 0 is less than or equal to x minus pi over 3. To 2 pi over 3. Do you see how that's the period? Do you see that there? That's the whole length. Now we have our phase shift to deal with, so we're going to add pi over 3. So I'm going to have pi over 3 less than or equal to x less than or equal to 3 pi. 2 plus 1 gives me 3. 3 pi over 3 is just pi. Question?
Why did you have to do the Bogford?
Yeah. I think the reason my preference, again, some books have bx minus c and they'll do c over b. I just like, you can kind of see, it's just a preference of order, that's all. You get to see the period and you also get to see what happens to the phase shift. Alright, because we're pushing it off to the right, I'm going to draw my first 5 points. And because I have a phase shift, I'm not actually going to draw the y-axis. So I have pi over 3, and over here I have pi. And if you're struggling with the fractions, just make them in denominators, common denominators. So I have 3 pi over 3. And I have a 1 there. So class, what's 1 plus 3? And 4 divided by 2 is? Now notice how you can't take half of 2 plus 3, which is 5, and 5 divided by 2. So you can double your fractions. 2 pi over 3 is the same thing as 4 pi over 6. This is 6 pi over 6. This is 2 pi over 6. And one nice pattern you guys see there. 2, 3 pi over 6, 4 pi over 6, 5 pi over 6. So I just need to reduce that, which becomes what? 5 over 2. And then 5 pi over 6. Let's go ahead and write down our x values. Pi over 3. Pi over 2. 2 pi over 3, 5 pi over 6, and pi. Alright, class, we're going to multiply each of these numbers by -2. What do you get? 0. -2. And then the last one, we've only been practicing for a day, so it looks a little tricky. You're adding 4. Everyone say add 4. So class, go ahead and add 4 here. Now it can help us to identify where all the numbers are decreasing, so I can put my y-axis over here. I know it's over here because of my phase shift to the right, pi over 3 units. 2, 3, 4, 5, 6. Just for fun, let's graph all of them so you can see what's happening. We can do that from here. So you recognize a phase shift of pi over 3, and then a period of 2 pi over 3. So that gives us 0, 1, 0, negative 1, 0. Not exactly the parent function, but... And then this is what happens when you do your vertical dilation of negative 2. It's going to flip your graph. So 0, negative 2, 0, 2, 0, and add some amplitude to it. And then the vertical shift of 4, so you're just going up 4 units. 4, 2, 4, 6. So the graph I want is in pink. So in this problem we graphed a bunch of different horizontal shift, vertical shift, amplitude with the negative.